I'm Narmatha, Assistant Professor, working in Dr. SNS Rajlakshmi College of Arts and Science in the Department of Cybersecurity. So in today's lecture, we are going to discuss about differential cryptanalysis. So in the last lecture, we have discussed about data encryption, standard decryption. So in the continuation of that, we'll see differential cryptanalysis. Differential cryptanalysis is one of the most significant and a recent advance in cryptanalysis. So it is known by NSA in 70s VS design. So it is a powerful method to analyze a block cipher. So you want to analyze a block cipher means we use this differential cryptanalysis. So it is used to analyze most current block cipher with varying degrees of success. So it is a statistical attack against fetal cipher. So it uses cipher structure not previously used. So the design of your DES algorithm, substitution and permutation network, has output of function F influenced by both input and key. So we are performing the permutation and substitution operations on a data, right? So that both thing will be taken here for the function F. Hence, it cannot be traced values back through cipher without knowing value of the key. So we should know the key. So without key, we don't find out the value what we want to get. So differential cryptanalysis, it eliminates key by using difference input. Differential cryptanalysis, it compares pairs of encryption. So it compares two related pairs of encryption with a known difference in the input, and it searches for a known difference in output when same subkeys are used. So if you're using same subkey for encryption and decryption means we have to consider two things. One is a difference in input and another one is difference in output. So by both of these two things, we can find out the difference in cryptanalysis. See, here they have given the formula what we are using to find out that. So we have splitted left hand side and the right hand side, right? So left half input to round I and mi to be the right half. So here we are taking the formula mi plus 1 is equals mi plus xr of mi m dash I plus 1. So again we are performing different operations. So here the what kind of thing we are using means we are performing the permutation operation. After permutation, the transposition is occurred. Then substitution and the expansion permutation will be occurred. So in this form, we are performing the differential cryptanalysis. So it takes the advantage of linearity. We are performing the transposition, substitution, and expansion. So by that way, this expansion permutation, it preserves differences like linearity between input and output values. Here we are performing the XOR operation. It also preserves the difference between input and output. And E, it changes the input in a known way. So difference changes in known way will be occurred. So it also takes the advantage of non-uniformity. All pairs of input with the same difference compute difference in output. All the input are same, but it produces the different output means it is not in the uniform way. That means it produces different output values from the input. So from this you can understand the differences between the input and output values. It has some input difference giving some output difference with probability P. If we find the instance of some higher probability input and output difference pairs occurring, it can also infer a subkey that was used in different rounds, and it also iterate process over many rounds. So it decreases the probability value. Based on that, it iterates the different values in different rounds. So the pictorial representation of differential analysis is given. So we are taking that formula along with that value. Here we are splitting left half, right half. So we have used the function that includes substitutions and permutations. So by that we are performing substitution, permutation, and the transposition operations. At last we'll get the result from that. So this performs attack by repeatedly encrypting plaintext pairs with known input XR until obtain desired output of XR value. So when we found out that particular match, the right pair will perform the XOR operation. If we didn't find out, that means the relative ratio for attack is different. So we can also deduce the key value for the rounds. So right pass that suggests some same key bits, wrong pass it gives a random values like that. So if we have used 64-bit input means, so if it doesn't have anything, a right pair of value means it uses same bit key bit. So it is a wrong pair means it uses a random values for. So from this lecture you can understand about the different differential cryptanalysis, how it is used in your block cipher and data encryption standard. Thank you.